Today we're going to look at graphing inequalities part 2. Part 2 is dealing with quadratic inequalities. Part 1 was linear inequalities. So let's go ahead and get our notes out and we'll get going. During the video, at any point, if you fall behind, remember to pause the video and keep your notes up. And if you didn't quite understand something the first time, pause the video, rewind it, and listen to it again. Sometimes it takes a couple times through to understand the concept. Okay, let's go ahead and get going. We're going to graph y is greater than 2 times x plus 1 squared minus 3. Now, graphing a quadratic inequality is very similar to graphing a linear inequality, where we have to find a boundary line that separates our solutions from non-solutions, decide if the points on the line are solutions or not with a solid or dotted, and then determine what side to shade, what area contains our solutions. All right, in fact, the only difference I see is we have to graph a quadratic rather than a linear equation. So let's go ahead and do that. Let's start with our boundary line. Okay, so the first thing we're going to look at is graphing our inequality as if it had an equal sign. This is our boundary line. So we have y is equal to 2 times x plus 1 squared minus 3. I also notice that our quadratic is set up to be graphed using shifts. Okay, we are in the form of y is equal to a times x plus or x minus h squared plus k. So what that means is we have an imaginary parabola, the parent graph, y is equal to x squared, sitting at the origin. Now, I'm not going to draw it in there because we're going to shift it first. All right, the shifts I see, the first one I see is our horizontal shift. It says plus 1, but we know because it's supposed to be x minus h that we simply have to go the opposite direction. If it says plus 1, we're going to move 1 to the negative direction, and that is our horizontal shift. I also notice that our vertical shift is a minus 3. So in that case, we're going to go down 3. So again, the vertical shift is opposite. It says plus 1, so we go 1 to the negative direction. The vertical shift, however, is what it is. It says minus 3, so we're minus or negative means down, so we're going down 3. So my new vertex is not at the origin, but it is 1 to the negative and 3 down, which puts it right here. I'm looking at A. Since 2 is greater than 0, that means our parabola is still opening up. It's not reflected or opening down. And it's also a bit shrunk. Sorry, it's also a bit stretched. It means it's narrow. It's a little skinny parabola. So we're going to next find the next points. An easy way to do this is simply plug in a value. Okay, so I'm going to go ahead and use a chart. I'm going to look up here and say, okay, my vertex is here. Now I'm going to choose my point wisely. I'm not going to choose -1 because I know that's my vertex. I'm also not going to choose 10. It's too far away. These things grow very fast. Our parabolas go very fast. I like 0. It's 1 unit away. So if x is 0, I know that y is 2 times 0 plus 1 squared, take away 3. Sorry, I lost my squared there. Which means 2 times 1 squared, which is 1, minus 3, or we have -1. So at 0, I know my parabola goes through -1. Symmetry says I have the same point, the same height, the same distance away. So 1 this way, it was 2 up. 1 to the left, it would be 2 up as well. Now, the next point I would probably choose would be 1. So let's go ahead and do that. And I chose 1 because it's the next point over and it's close, and I know that, again, this thing grows fast. So this is 2 times 1 plus 1 squared minus 3, which equals 2 times 2 squared minus 3, which is 8 minus 3, or 5. So my next point is at 1, 5. You can see how fast that grew. Now symmetry says I have the same point, the same height on the opposite side. Again, it's a reflection. So it's about right there. Okay, next point, next step is to figure out, is it solid or dotted? How do we connect the boundary lines? Are the points on the line included or not included? Again, because this is a greater than sign, means So dotted line, points on the line are not solution. Make sure you understand that. If it was a solid line, then points on the lines are solutions. Sorry, we're getting our work kind of crammed in here a bit. So I'm just going to draw a line. This is our side work right here. All right, so dotted line, here we go. Just going to rough sketch it in there. Looks something like that. And lastly is shading. And again, if you can't see what is the less than side and the greater than side, a lot of times we can see that and shade it. We're just simply going to pick a test point. Now my favorite test point is 0, 0, but that is so close to the line, I don't want to use that one because our graph may be inaccurate. I may choose the wrong side. I like this point right here. It's right in the middle. And that point is -1, 0. Now you can choose any point you want. I like that one because it's right in the middle of everything. It's away from the lines. So I'm going to go and say y is greater than 2 times x plus 1 squared minus 3. I'm going to substitute in our point where y is 0. So that's 0 greater than 2 times, and our x is -1, so -1 plus 1 squared minus 3. And I know that -1 plus 1 is 0. 0 squared is 0 times 2 is 0. So after much simplification, I get 0 is -3. And what we're doing is we're testing the point to see if it's a solution or not. And because we come out with a true statement, 0 is indeed greater than -3, that is a solution. That also implies my solutions are on that side of the boundary line. So I can shade this side of the boundary line. This is where all my solutions to this inequality lie. Okay, the old way to do it, we used to just scribble it all in, but because we're moving into systems, we want to just make sure we draw little arrows to keep our graphs nice and clean. And again, if this was false, then it implies the other side is where our solutions are. So true means shade that side of the point you chose, false means shade the other side. So to recap, we graph our boundary line simply by looking at the equation. Then we decide if the points on the line are solutions or not. I mean, do I connect them with a solid or dotted? And lastly, we pick a test point and see if it's true or false. If it's true, we shade the side of the test point. If it's false, we shade the other side of the boundary line. Okay, if you have any more questions, please write them down and we'll handle them in class. Thank you.